In this video, we're going to learn how to graph the trigonometric functions using key points, which is really the ideal way to graph these by hand. Now, what I mean by this is we're going to take a trigonometric function's period and divide it by 4 so we can more easily graph them just using 5 key points. So first, sine of x has a period of 2 pi, meaning every full revolution of a circle, it repeats its values over and over. So if I look at my angles here for what I'm going to plug in, and I only go from 0 to 2 pi and divide it up evenly amongst the rest of the interval into 4 equal parts, I will have 5 points to graph, and they should ideally be the best 5 points for us to follow. So if we take 2 pi over 4 and divide it by 4, we get pi over 2. So meaning start at 0, if I add pi over 2 over and over again, I should get all the key points and it'll add up to 2 pi. So 0 plus 2 pi is pi over 2 is pi over 2. Pi over 2 plus itself is 2 pi over 2, which is just pi. 2 pi over 2 plus pi over 2 is 3 pi over 2. And then 3 pi over 2 plus pi over 2 is 4 pi over 2, which is 2 pi. Now, the y values that go along with this, sine of 0, we learned from the last lesson, is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0. So I'm going to plot these 5 points. So 0, 0. Pi over 2, 1. Pi, 0. 3 pi over 2, negative 1, 2 pi, 0, and if I just draw a nice curve through these points, you can already see that I've made my sine function. It's a very quick process, which makes graphing multiple periods of this a lot easier, because now I can follow that same pattern. I went from 0 to 1 to 0 to negative 1 to 0. Now that 0 should go to 1, and then back to 0. To fill out the graph. And if it's at 1, 0 going backwards, to go back to negative 1, 0, 1, 0, negative 1, 0, every pi over 2, put in a new point. And again, you'll start to see that this is a nice wave for the sinusoidal function. And already we've graphed a length of 6 pi for this function, and it took us 2 minutes at most. Again, we can do this for every function. In fact, I'm going to, so you can know what your key points are going to be for any given trig function. So cosine of the period is 2 pi. So again, divided by 4, so it could be pi over 2. So I should end up with very similar x values, that same ones I did for sine. But this time my y values will be different because cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. So now we start at 1. And then we go to 0 for pi over 2. And then negative 1. Then 0, then 1, and there you go. Here's one cycle of the trig function. And again, very easy to repeat this process. I went 1, 0, negative 1, 0, 1, then it would be 0, and then negative 1. And going backwards, a very common mistake to happen going in the other direction. Sometimes you'll mainly see happen with sine a lot. You'll be like 1, 0, 1 and try to make it symmetric, but only cosine has that same symmetry. So now from 1 I go back to 0, then negative 1, then 0, then 1, then 0, then negative 1, and a very similar pattern. That's your cosine function. Be a little careful when you're drawing it. I got a little lazy here. You saw I kind of went up a little too much. That's usually the peak, and it goes straight down from there. I did the same thing over here, but I just got a little bit lazy. That's all. Now with tangent, the period for tangent is just pi. So it repeats itself every pi. So if I divide pi by 4, that is pi over 4. If I add that to 0, I get pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2. And then 2 pi over 4 plus pi over 4 is 3 pi over 4. And 3 pi over 4 plus pi over 4 is pi. 4 pi over 4, which is pi. Plugging in these values into tangent gives me 0, then 1, and then undefined, -1, and then 0. So 0, 1, undefined, which we learned in the last lesson, just means an asymptote. And then -1, and then 0. Now you'll notice here I already made a mistake because I was not counting what's going on down here. But this is pi over 2. So I'm going to fix this right now and call it pi over 4. This one we'll call pi over 2. This will be 3 pi over 4. And this one here will be pi, which would cause this one to be 5 pi over 4. And then 3 pi over 2. Just so it's very consistent. And I'll make sure I fix it for the graph on the next page. But I will continue the same pattern over and over again. So if this was -1, 0, then after 0 follows 1. And then an asymptote would follow from there. But again, if you ever make that mistake, just like I did, you can always redefine your x-axis to count by a different amount. And since these are periodic functions that repeat their patterns, as long as you follow that same pattern along your x-axis, it should be fine. Again, going backwards, again, this is going to be -pi over 4, then -pi over 2, -3 pi over 4. And again, I'm just counting by pi over 4s down here. -pi, -5 pi over 4, -3 pi over 2. Backwards, if this was 0, this will be -1. And then an asymptote at -pi over 2. And then after the asymptote here, it will be at 1, 0, -1, then another asymptote. And we just graphed 3 cycles of that function pretty quickly. Now let's look at cotangent. This time I won't make that mistake of counting incorrectly along my x-axis. So again, the cotangent period is pi as well, so it's going to have the same x value angles to plug in. Okay, so it'll count by pi over 4s as you go. And again, every tick mark here is pi over 4. So I just have to count the tick marks along my x-axis to graph this correctly. But cotangent of 0 was undefined. Cotangent of pi over 4 was 1. Cotangent of pi over 2 was 0. Cotangent of 3 pi over 4 was -1. And then cotangent of pi was undefined. So again, I have an asymptote to start out. And that pi over 4, which should be this first tick mark, it's 1. Pi over 2 is 0. 3 pi over 4 is -1, and then another asymptote. And then I create my little swirly function through. And I can continue the same pattern. So after the asymptote follows a 1, then a 0, then a -1, then an asymptote. And then a 1, a 0, a -1, then an asymptote. And you're seeing I'm just following this very familiar pattern every time with this function. And it's helped me graph this very quickly. If I went backwards, after the asymptote would be -1, 0, 1, then an asymptote. Again, the mistake here sometimes could be that asymptote 1, 0, -1. But again, we're following that same pattern to the left and keeping that same pattern going. So we're always in this kind of like downward curve the entire time. -1, 0, 1, asymptote. -1, 0, 1, asymptote. And that's cotangent. And that's more or less what tangent should look like if I counted it correctly. You should have seen like roughly 5 or 6 cycles of tangent. Now cosecant, its period is 2 pi. Which means we're going to have a very similar counting method as sine and cosine. And when we plug, we know cosecant's 1 over sine of x. So when we do sine of 0, that's 0, so that'll be 1 over 0, causing this to be undefined right away. So an asymptote to start the function. Then cosecant of pi over 2 should be 1 over 1, so that'll be 1. And then cosecant of pi is 1 over 0, so that should be undefined. And then cosine of 3 pi over 2, cosecant of 3 pi over 2 should be 1 over -1, which is -1. And then cosecant of 2 pi should be 1 over 0, which is undefined again. So we have these very clear asymptotes at 0, pi, 2 pi, and it seems to happen every pi. So I'm going to draw them all in right now. And if you remember this function from the last video, this is where we had all those cups form. Because you're seeing here, I'm only going to be given 1 point between each asymptote. So it's going to be very important that we know this looks like a cup. There is also another way to think about this function to help you graph it as well. So again, alternating between each asymptote. If I follow the pattern, and again, this key points just gave me these 2 points, but I can follow that pattern pretty easily. And this will create these little cups that go upward from the point. Or downward from the point, but never touching the x-axis. Another tool you can use to graph cosecant as well as secant in just a little bit is you can actually use its reciprocal to help guide you. So again, sine would have been 0, 1, 0, -1, 0. And if I just kind of lightly tap it in so it doesn't distract from the main graph, you'll see here that the cups kind of just turn away from the sine function. You can kind of use that as a guide to graph it, and every time that this function was 0, that would be 1 over 0, so that would be an asymptote. So it could be a nice guiding point to help you graph these functions. Every time it crosses 0, draw an asymptote, and at its peak or its dip, you're going to make a U cup and turn it away to graph it. And again, the little dashed line there is sine of x, but it shouldn't be the focus of that graph. So if you're ever going to use that method for drawing sine of x to help guide cosecant, I would definitely make it a dashed and very light line so it doesn't distract you from what the graph should look like. Now lastly, we're talking about secant, which is 1 over cosine. So its period is going to be similar to cosine, which is 2 pi. So 0 to 2 pi, break it up into 4 pieces by dividing by 4. We've seen this pattern a few times already in this video. But now, secant of 0 is 1 over cosine of 0, which would be 1 over 1, which is 1. Then secant of pi over 2 would be 1 over 0, which is undefined. Secant of pi would be 1 over negative 1, which is negative 1. Secant of 3 pi over 2 is 1 over 0, which is undefined. And secant of 2 pi would be 1 over 1, which is 1. So you're already starting to see this pattern form. You can always look back at the other graph in case you don't believe me. In the last video we did what those graphs and what they look like. But again, following this 1 is probably going to be another asymptote, followed by a negative 1 like we saw earlier, following that asymptote, and then going backwards. This would be negative 1, asymptote 1, and then an asymptote, and then a negative 1, asymptote, and then a 1, and then asymptote, and then a negative 1. And again, if you needed the help, cosine would be 1, 0, negative 1, 0, 1, 0, negative 1. Look back at the last graph, and again, I could use this as a guiding way of drawing secants. Because now this dashed line I'm making, I just have to turn away from it at every point. And every time it crosses 0, I have an asymptote, so that's perfect. So as I draw it, it curves away from the cosine graph. It makes all these cups. So as you can see, even though I was explaining my way through this, this is a very quick way to draw all these trig functions using key points. And it's actually the way I'm going to go about it in every example from here on forward. And this is how you graph trigonometric functions using key points.